Hello. We are going to go over quiz 10. So this is the second part of hypothesis testing. Okay, so let me start from the easiest question. So the first question, the production manager of a manufacturer wants to evaluate a modified ball bearing production process. When the process is operating properly, the process produces ball bearings whose weights have a mean of 5 ounces and a standard deviation of 0.1 ounce. A new raw material supplier was used for a recent production run, and the manager wants to know if that change has caused any problem. If there was a problem, the mean weight of a ball bearing would be different. The manager will test the following hypothesis. The null hypothesis is that the true mean equals 5, and the alternative hypothesis is that the true mean is different from 5. From a random sample of 100 ball bearings, the sample mean was 5.04 ounces, right? 0.04 ounce difference. The significance level is specified as 1%. What is the probability of type 1 errors in this hypothesis testing? Okay, now the question is pretty long, but actually, so it sounds very complicated, but it is a free question as long as you remember this. Type 1, I'm asking you what is the probability of type 1 errors. Simply find the significance level. I already gave you the answer. So without any algebra, it is 1%. So that is it. This is how you solve it. How you are supposed to solve it. Okay? That's it. Okay? Second question. A researcher wants to study the average lifetime of a certain brand of battery in hours. The testing hypotheses are: the null hypothesis is that the mean lifetime, true mean lifetime is 1,000 hours, and the alternative hypothesis is that the true mean hours is different from 1,000. Suppose that the standard deviation of the battery lifetime is known to be 375 hours. The researcher plans to draw a random sample of 900 batteries and measure their lifetime. So I use 900 sample size, whose square root is 30. Okay. She decides to reject the null hypothesis if the observed sample mean is different from 1,000 hours by more than 25 hours. Find the type 1 error probability based on the researcher's rejection rule. Okay, so I'm asking you the type 1 error probability again. So you may think, yeah, you know that this is simple if the significance level was given. But actually, here is another trick here is that the decision rule is not based on the significance level in this case, right? So decision rule is like this. Reject the null hypothesis if sample mean x bar is different from 1,000 by more than 25. So if x bar is outside 1,000 plus minus 25, then you reject the null hypothesis. So it does not use significance level approach. So actually, it is not statistical hypothesis testing approach, but basically it's mechanically the same thing. So still, you can calculate the type 1 error probability. So you can understand this value. 25 is arbitrarily chosen margin of error. So 1,000 plus minus 25 is arbitrarily chosen critical values, right? So usually critical values must be derived from significance level, but in here, this researcher does not know how to do it. So choose just arbitrary number. Okay, let's see what happens. So then typically if you calculate the type 1 error probability using algebra, then you have to go through these basic steps. I'm going to divide the work into 3 steps. First, you have to find the critical values. But in this case, critical values are given. So 1000 plus minus 25 are critical values. So step 1 is given. Step 2, find the parameters, the normal distribution parameters for X bar sampling distribution, right? So we are going to use the normal approximation for X bar. So we are going to find the normal parameters for the distribution. But in doing so, we need to assume that the null hypothesis is true. That is because we are calculating type 1 error probability. So type 1 error happens when the null hypothesis is true, but you reject it. So anyhow, to calculate for the type 1 error to happen, the null hypothesis must be true. So we are assuming that. And in the final step, you are calculating the probability of rejection. So again, type 1 error probability, type 1 error happens when you reject. So you have to calculate the probability of rejection here. Okay. So as I said, critical values are given. So we are going to skip the first step. Let's go to the second step. So we know we are going to use the central limit theorem, normal approximation. And if you assume that the null hypothesis is true, that means the true mean is 1000. So if that was true, 1000 is the true lifetime mean. And the standard deviation is known. But by the way, we are calculating the standard deviation of X bar. And we know that is given by S, which is standard deviation of a single observation divided by square root of the sample size. So, for a single observation, single battery, the lifetime is the standard deviation is 375, and the sample size is 900. Using them, we get 12.5 for the standard deviation. This is the standard deviation for this normal distribution. Okay, that is step 2. So we are going to use these two numbers for standardization. So let's go to the final step. So we are going to calculate the probability of rejection. So remember, we are going to reject if X bar is outside 1000 plus minus 25. That means reject if X bar is smaller than 1000 minus 25 or greater than 1000 plus 25. So we are going to use, we need to consider both sides because it is two-tailed test. Okay, so but not a big problem. We are going to standardize X bar into Z and standardize these numbers, critical values, using the mean 1000, standard deviation 12.5. Okay, so do that, and then you are going to get easy, simple numbers. I designed the numbers to have simple numbers, -2 plus 2. So then you know how to calculate that, okay? So, like, for example, on Excel, So, let me show you how to do this. You remember. So, I use this formula, normal.s.dist, and -2, and you set true. Option is true. The option for the cumulative probability is true. Then this is the probability less than -2. So simply let me use this probability. And this is probability smaller than -2. So the first probability is that, and the second probability is the same as the first one because the normal distribution is symmetric. So you can simply multiply this by 2, then you are going to get this probability. So 4.55% is the type 1 error probability here. Okay, so even if we did not specify the significance level, but as long as you have well-defined critical values, then you can calculate type 1 error probability. Okay. So next question. the manager of a firm wants to determine if the average hourly wage for semi-skilled workers is $9 in the capital district. In order to do so, she takes a random sample of 100 hourly wages and finds that the sample mean is $8 and the sample standard deviation is $2. The hypotheses to be tested are the null is 9 and the alternative is different from 9. So it's two-tailed test. Assume that the actual average is $8.9. What is the probability of type 2 error at the 5% significance level? Okay, so now you have to calculate type 2 error probability, which requires some algebra. So remember again, the definition of type 2 error is that it is a failure to reject a wrong null hypothesis. Okay, so we are going to do this in 3 steps. First, actually these 3 steps are exactly same as what you have done for the previous question. First step, we need to determine the critical values. That basically we need to determine when we reject. We need to determine the rejection rule. And the second step, we assume that the true mean is different from H0, the null hypothesis. Assume a true mean, and then find the normal distribution parameters for X bar based on the assumption. Okay, and the last step, we calculate the probability of acceptance, not rejecting, probability of non-rejecting the null hypothesis. That is when type 2 error happens. Okay, so of course in this process we are going to standardize the probability using the parameters we obtained in the previous step under the assumption of a specific truth. Okay, true values. Okay, first step, we need to calculate the critical values. So because it is two-tailed test, our critical values will be your belief plus minus z-value times standard error. But here the value is based on alpha over 2 because it's two-tailed test. Alpha should be split on both sides. So let's see what happens. So here we are using 5% significance level. So then, so significance level is 5%. And we are going to split this into half. And we will take 1 minus the half to make it a cumulative probability. So this is significance level. So this is probability on one tail, one side. And this is cumulative probability. And then finally, we are going to calculate the inverse of that cumulative probability. Then you are going to get this number, which is commonly used. This is z alpha over 2. Okay, so that number is what we are going to use here. We are going to use 1.96, and all the other numbers are given. Your belief is 9. Standard deviation for a single wage is $2. Sample size is 100. So plug them in, then calculate. Then you are going to get critical values 8.608 for the lower critical value, and the upper critical value is $9.392. So remember these numbers. We are going to use them to calculate the probability. In step 3. In the second step, we need to find the parameters we are going to use. Now what we are doing is we assume that your belief is wrong. $9 is wrong, but the truth is $8.9. The truth is 8.9. So then the normal distribution, so when you approximate X bar to a normal distribution, its mean should be 8.9, which is according to our assumption. And the standard deviation is not affected by your belief, so it is just coming from these two numbers. In the question, I specify the standard deviation as $2, sample size 100. So standard error is 0.2. So use these two parameters and use these critical values. So you are going to calculate the probability of not rejecting the null hypothesis, right? So you don't reject the null hypothesis if x bar, the sample average, is in between these two numbers, the critical values. But so you are now we need to standardize x bar into standard normal distribution z, and to do that we use the mean 8.9 and standard error 0.2. So calculate standardize the critical values, and you will get minus 1.46 and plus 2.46. Okay, so you calculate the probability, this probability from the normal distribution. To show you how to do that, like this. First, you calculate probability, cumulative probability for the larger number, 2.46, and calculate the cumulative probability for the lower endpoint, like this. Let me check if it's correct. 2.46 minus 1.46. Okay, yeah, correct. And take their difference. Then that is, so this is that probability. This is the probability, the type 2 error probability, right? So you are going to make type 2 error with 92%, because $0.1 difference is too small to detect. Okay. Next question. A government agency receives many consumer complaints that the boxes of detergent sold by a company contain less than the 20 ounces of detergent advertised, right? So advertised as 20 ounces, but actually the amount is less than that. So to check the consumer's complaints, the agency purchases 100 boxes of the detergent and finds that the sample mean is 19.3 ounces and the sample standard deviation is 4. The agency conducts a testing of the following hypothesis at the 1% level of significance. So as you see, it is one tail test. Particularly, it's lower tail test. So you are going to reject only if the sample average is too low. If it's large, that is not a problem. Large sample average does not reject your null hypothesis. But rejection happens only when it is too small. So anyhow, we are going to calculate the p-value and make the decision. To calculate the p-value, first we need to calculate the t-statistic. So the t-statistic is like this. So your sample average and your belief, calculate the difference and standardize with the standard error, right? So your sample average is 19.3, your belief is 20, and the standard error is 4 over square root 100. So calculate that, you are going to get minus 1.75. That is t-statistic. Okay. So now you need to calculate the p-value, but the p-value in this case is the probability only on the lower side, lower tail, because it is one tail test, right? So when you have two tail test, the p-value includes probabilities on both tails. But here, we don't care about larger side, positive errors. So you are only considering probability lower than the actual t-statistic. T-statistic was minus 1.75. So calculate probability lower than that. You know how to do it. So on Excel, if you calculate that cumulative probability, you are going to get approximately 4%. Right? And now you need to make the decision. This p-value is greater than your significance level, so you do not reject the null hypothesis. Okay, that is the rule. So if the significance level was greater than the p-value, you have to reject the null hypothesis, right? The p-value is too small. However, in this case, p-value is greater, so we do not reject the null hypothesis. Okay, so I wanted to show you how we conduct the one-tailed test. But basically, it's the same thing. P-value, t-stat p-value, and the rejection rule are similar. Just consider only one side. Next question. The sales manager of a food company wants to determine if the weekly sales of 16-ounce packages of frozen broccoli has increased since last year. The mean weekly number of sales per store was 2,400 packages last year. The sales manager set the following hypothesis to test. So null is 2,400 and alternative is greater than that. Available sales data are from 400 stores. Assume that this data set is a random sample. The sample mean is 2,420 and the sample standard deviation is 800. For the significance level of 1%, find the critical value. Okay, again, it is upper tail test, one tail test, but it is now upside, right? Reject if sales is greater than 24, then we can conclude that our sales increased this year. I don't believe or I don't care if it's lower, right? It is unlikely to decrease over time, so we are going to ignore the lower side shock, lower side problem. Okay, now we are going to calculate the critical value. When you calculate the critical value, you have to be careful which side you are rejecting. I am rejecting only on the upper side. So, two things change it here. First, here the sign is not plus minus, but it's only plus because we are looking at only on the upside. Also, here z alpha over 2 is changed to z alpha. So now we do not split probability alpha on two tails, but whole alpha is put only on one side. So this is how we calculate the critical value now. So these are two differences. The sign and alpha, these are the differences. And let me compare what we do. So the left-hand side, this was two-tail case, two-tail test, but we can do that for, excuse me. So now let's see what is the difference. So for example, if you think about 0.05 and what we do here is, here you do not take half of the significance level. We are going to put the same probability on one tail. So here the other step is the same. We change this to the cumulative probability by taking 1 minus the probability, and then we take normal distribution inverse. Then you will get this number. So by the way, back to question. We are using 1%. So let's change it to 1%. Then you have to use 2.33. It is z alpha, not z alpha over 2. So z alpha is 2.33. So use that here. And mu 0 is 2400. Standard deviation 800. Sample size 400. That's all you need. Calculate the critical value. Right? That answers the question. Next question. A researcher wants to test whether the average college student watches videos on YouTube no less than 20 hours per week. I'm really curious. She sets up the testing hypothesis as 20 or less. So she believes that the YouTube hours is no less than 20 hours. So if it's greater than 20, she's still correct. So what she worries about is she's wrong only if the hours is less than 20. So reject the null hypothesis only when the realization is less than 20. Seriously less than 20. Okay? And she finds that the mean number of hours college students spent on YouTube was 19 hours. And the standard deviation was 5 hours from a random sample of 100 college students. She wants to use a non-conventional significance level of 6%. Find the critical value for the hypothesis test. So it is similar to what we have done here. We are going to do the same thing. Here. The key difference is now we are going to reject if it's too small, if the sample average is too small. So rejecting on the lower side. So you have to change the sign to minus. Earlier in the previous question we considered plus here, but now you have to use minus here. And this is also z alpha, right? Not alpha over 2, right? That is same as before. Another strange thing here is significance level is 6%. So you have to find the correct z alpha by yourself from Excel, right? I made already worksheet. 6%, if you put 6%, you will get 1.55 here. Okay, so anyhow, you are going to find z alpha. So z alpha is top alpha probability value. In other words, below this value, there are 94%. So this cumulative probability is 94%. Use this cumulative probability information from Excel, you get 1.55. Then you know all the numbers. Oh, it's typo. So I copied the numbers from the previous question and did not change anything. I'm sorry about that. So, you know, this is how you calculate the critical value. Okay? Okay. Then next question. Suppose an auto manufacturer states that their car goes from 0 to 60 miles per hour in 10 seconds or shorter on average. So goes from 0 to 60 in 10 seconds or shorter on average. You suspect a claim and set up the following null and alternative hypothesis for a hypothesis test. So your null hypothesis is that you believe the claim. So the time from 0 to 60 is 10 seconds or shorter. But if that's wrong, you need to reject your belief. So that is when the mean is greater than 10. So also in this case, it is an upper tail test. If it's shorter than 10, then the car is good enough. So you don't need to do anything. But if it's longer than 10 seconds, significantly longer than 10 seconds, then the advertisement is wrong. So the car maker could be in trouble. Okay, let's think about this. And from 900 experiments, the average was slightly greater than 10 seconds with standard deviation 5 seconds. Use 1% significance level. What is the probability of type 1 error? Okay, even if I read it long, but we don't need to read anything. You just need to look at the last sentence. No matter what the numbers are, I don't need to know them, but you just need to know type 1 error probability equals the significance level. 1%. The answer is 1%. You don't need to care about anything else. Okay. Next question. The manufacturer of a new compact car claims that the car will average at least 35 miles per gallon in general highway driving. For 100 test runs, the car averaged 35.5 miles per gallon with a standard deviation of 4 miles per gallon. Suppose that the manufacturer tests the following hypothesis. Okay, so now it is upper tail test. So because if the mileage is 35 or lower, good, you are good. But if it's actually, oh, excuse me. Yeah, it's a problem in the question. So enlist, so I'm sorry. So let me follow this inequality. So based on the context, it should be lower tail test if the test is, I mean, excuse me, put it this way. So you want to make sure, you are a manufacturer, so you want to make sure your claim is right. So you are going to unfavor your own claim. You are putting your claim as the alternative hypothesis. So if you can reject the null hypothesis, that means your claim is very, very strongly supported by this hypothesis testing. So let's understand it that way. So consider the 5% significance level. What is the power of the test if the actual average fuel efficiency is 36 miles per gallon? Okay, so we are going to follow this, right? Upper tail test. So we are going through the same 3 steps. By the way, the power is the probability of correctly rejecting a wrong hypothesis, right? So if the null hypothesis is wrong, you should reject it. That is the power, okay? And 3 steps, which is similar to calculating type 1 or type 2 error probabilities. First, determine the rejection region, the rejection rule. And second, assume a true mean that is different from the null hypothesis. And then find the normal distribution parameters for x bar. And 3, calculate the probability of rejection, because power is when you reject. Power happens when you reject, so you are calculating rejection. Okay, first let's think about critical value. Now we are rejecting on the upper tail, so here you are using plus sign, and Z alpha is coming from 5% significance level. So back to our worksheet. If you use 5% significance level, you will use 1.64. That is your Z alpha. So you know mu0 is 35. This is, oh, typo. Oh, excuse me. It was stupid mistake again. 1.64. So I am demonstrating you, like it's confusing, so you don't make mistake like me, right? So, and, so mu0 is 35, Z alpha is 1.64, standard deviation is 4, sample size is 100. You know all the numbers, so you get 35 point something. This is wrong. So this number is wrong. This number is wrong, so you have to recalculate that number, but you can do it. So recalculate this number. You should be able to calculate that number. And then, second step. Now, we assume that the actual average fuel efficiency is 36 miles per gallon. So we assume 36 is the true mean, and standard deviation is still 4 with 100 sample size. So the standard deviation for x bar is 0.4, 4 over square root of 100. Okay, so 2 parameters are given. We use that to calculate the probability. By the way, this is wrong. I made a mistake in algebra. So this is wrong. This is wrong. The number is wrong, but like assuming that if this number was correct, if the number was correct, we are going to standardize. By the way, we are calculating rejection probability. So remember, we are rejecting only on the positive side if it's too large. So we reject if the sample average is too large, and standardize the critical value using the parameters we obtained in second step. And then again, this is wrong, and this will be different. And but it is not that difficult. Recalculate this number, then standardize this number again, and then you are going to get a number here. Then you can find the probability from Excel, right? So that is not a big problem, I believe. Okay, this is it. This is quiz 10, and we have done a lot of, you know, algebra, but basically, as you could see, most of the algebra is the same algebra we have done since chapter 6, right? So just I want you to understand the intuition, then you will see it is pretty straightforward. Okay, thank you for watching, and we have only 2 more chapters to go. Okay, it's getting cold, so please stay healthy and see you later.